Yeah, I didn't know if you guys have a time limit. Sorry.
Go for it.
I probably need to leave it like.
I have to be home by 6 because that's when my daughter needs to.
If we're still here at 6, I will not be happy.
Yeah, no, neither will I. Okay, dynamics refers to Newton's 3 laws, so we'll go through those first. Who has never heard Newton's 3 laws?
Oh, energy can never be created or destroyed. Okay, those are different
The
ones.
second.
I don't know if
Is that a
object
never, or
creates
you think
motion.
you can guess?
I think if you named them, I'd be like, oh yeah.
Duh.
But like I couldn't name them.
Something in motion stays in motion.
That's number 1, yeah.
Unless acted upon by an outside
everything
force.
acted by an opposite and equal
I have
reaction.
one more.
Okay.
All right, yeah,
If you
he's that.
fill Newton with fig, it tastes really good.
Okay.
I don't know.
I
That's
actually
Newton's
don't like
law.
the Newtons. The first one has 2 parts to it. There's motion and there's at rest. And it was just like Jared curses. Yes?
Yes.
Okay. Just like Jared started saying, there's 2 parts to it. So what did you say? Or you just
Motion
saying-
stays in motion.
Okay, yeah. The part that most people forget is the
Unless acted upon by an outside force.
yeah, with no outside force. So that means if it's going one direction without anything acting on it, it's going to keep going that direction. So another part to this that is forgotten is it's in a straight line. Now, is this completely multiple choice? Because I never remember.
Yes.
Yes.
Okay. A common question on this one, which is counterintuitive to a lot of people. If I take, and I have accidentally hit people in the head with a tennis ball trying to do this in class. If I take a tennis ball on a string and I swing it around my head, I let go of it, what
And
direction does it
it
go?
goes like this.
Okay, so let's say I'm going this direction. Taylor, no, it was TJ.
Yeah.
Okay, I remember I called you Taylor for like the longest time. If I let go right there, what direction does
It's
it go?
gonna go this way.
This way?
Just
That
no,
makes
like just whatever way
No,
you were.
no, you said this way. Okay, it is this way. What's it, what?
Well, you have the right idea. She just drew it weird.
I'm sorry. What direction are you thinking?
I really.
Okay.
The way it's going when you let it
That
go.
looks right.
Okay, yeah. At this exact moment, what direction is it going?
What's that
That
on
way.
my nose, Colin?
Okay, what's that called?
Tangent.
There you go, yeah. So if it's moving in a circle, it always goes tangent to where you let go of it. So wherever here, it's a common question, a lot of multiple choice tests about Newton's laws. So wherever they are, or sorry, wherever they're moving to, they go in a straight line as long as there's no outside force. Obviously, if there is a force, then you have to go to Newton's second law. We'll get to that one in a second. Okay, rest is a lot easier because if it's
An
sitting
object at
somewhere-
rest tends to stay at rest.
Yeah, it's just gonna stay there. And again, it has to include with no outside force. Okay? Yeah.
Can I guess the third one? Is it?
What did I get?
Oh, okay. Take your time.
How about 2? Anyone know 2? It is not very commonly,
5.
they actually are above your heads.
No cheating. We're gonna guess.
There's a reason you don't take these
All
tests
motion
in here.
requires energy. I don't know. Is that one of
No.
them?
It's behind you, actually. Number 2 doesn't have like a cool statement to it. It's actually more or less just a formula. F equals ma. You heard that one?
Force equals mass times acceleration.
Yeah. First of all, mass always has to be in kilograms. Okay. Acceleration should be in meters per second squared. For the most part, this is a plug and chug problem. Take whatever numbers they give you, plug them in where they go, solve for the one that they're leaving out. The force here has to be net force. Sorry, that is an E in my pen cut out. Okay, so for example, let's say that Mark is pushing this way with 60 newtons, and Colin is pushing that way with
100 newtons.
240.
You're not-
Ouch.
You're the only one I don't know. What's your name?
Hi, I'm Tyler.
Okay.
He's a junior, so you wouldn't know him yet.
Yeah.
Pretty sure that's a fat joke because 60 newtons would be more mass, maybe, unless it's.
60 newtons is
Then that
more
means he's stronger.
force.
Force.
Yeah, so she's-
It means I'm stronger than Colin, which it might not.
You
Yeah.
can't just pick numbers.
Force equals mass times acceleration, so if you're heavier, you'll have a greater force.
Blah, blah, blah.
Yes.
That's true.
Anyway,
Okay, whatever.
sit
So
on
with this
someone.
net force, you would have to consider that these are canceling each other out in some amount. So what's the net force?
20 minus friction.
20, yeah, 20 that direction.
20 minus friction?
Yeah, friction kind of
Okay,
murders things.
almost 99.9% of the time, they're going to say ignore
Ooh.
friction.
Yeah, ignore outside forces.
Yes, because I will tell you, in 4 years of college, I did not get to put friction into the equation until my junior year. Okay, we spent the first 2 years going, this is how you do it, ignoring friction, then we started putting it in. And that's after you had to take crazy math classes. So,
Friction sucks.
yeah, friction throws in quadratic equations and differential calculus, which is, I'm going to guess, way above what they do on this test, correct?
Oh,
I
well.
sure hope so.
And I'm pretty sure if I was given a problem right now, I would be sitting there for about an hour before I even remember that, because that was about 7 or 8 years ago.
Yeah.
Totally just dating
Differential
myself. Okay, what?
calculus? Differential calculus and.
Well, calculus, one thing, I meant like second year calculus. It's been on that one. Calculus is,
We haven't done differentials yet.
yeah, this is actually, are you in AP Cal?
Yeah.
That
Other
covers,
than him.
at BYU, that covers 112, and then you have to take 113, and then you have to take 214. I'm talking 214, which is, it was a fun class. But anyway. Okay, Colin, you wanted to guess 3? Hi, Charlie.
No, I changed my mind, just
You
tell
didn't
us.
terrorize your sub, but we will set another date.
Oh, yeah.
Is it the law of conservation of matter?
No, that's a different guy.
TJ, I think you said it at some point.
Oh, that's biology.
I don't know. Oh,
No, that's biology,
Or
chemistry,
actions
and
has an
physics.
opposite and
Yeah.
equal reaction.
This depends.
Each action has an opposite and equal reaction.
No, yeah.
Okay. Ah. Okay, so for every
Conservation
action.
matter.
There's an equal reaction.
Yeah, blah, blah, blah. Okay, there's an equal and opposite. An example of this one, this is common, I actually think this has been on a test somewhere, maybe, I don't know. If you have a book sitting on a table, that is quite obviously the book sitting on a table.
Of course.
And the book is pushing down on the table with, let's say it's a relatively light book, 10 newtons. The table therefore is pushing back with, okay, yeah.
Unless the table's made out of jello.
Yes, then you'd have to add in.
Then it's
can
like
the
then
table
it's like
actually support 10
6.
newtons? What's that?
Then it's like 6 newtons because it's kind of
Well, then it starts sinking.
yeah.
Now it's gonna reach a point where it has enough jello bent, okay. This one can be tricky because a lot of times they'll throw in, let's see, like this is the force we're thinking of, and they'll be like, oh, well down here, the ground is pushing up with 60 newtons. Are these paired with each other?
No.
No. Okay, if I say this, how did I say it?
Is that because the table's 60?
Yeah, in this case, yeah, I could reason that the table is 50.
So the table's talented. It's pushing up and down at the
50
same
in
time.
book 10.
What?
But wouldn't the table, that'd make the table 50 in the book 10 though,
Yeah.
right? Or do you even have to worry about
50
that?
and a buck 10? No, I'm
No.
not hearing what you're saying. What?
I said, wouldn't that make the table only 50 though, and the book the other
Yeah,
10?
it is.
Well, yes, in that case, that is a pretty heavy book in relation to the just go. I just made up numbers.
Okay.
I'm sure whoever wrote the questions actually sat there and made the numbers,
It's Mrs. Smith.
even though she quit.
Oh,
Anyway,
sad.
she quit this year. So.
I'm not in
I've been out
science
of
yet.
the
Loop.
gossipy loop. Yes. Sorry, I spend most of my days. I think there's actually spit up on you right now. All right. So the way that I phrase this book applies 10 newtons to table. The pair to this, just flip it. Has to be table applies to book. A lot of times they'll throw in another force that has something to do with it, but is not paired with it. Okay, so that's just a common trick I see on a lot of these tests. Okay, any of these that you're never heard of before, need to go over again? These tend to be, didn't you cover these in like ninth grade Earth systems or something?
Tiny,
So.
a little.
Possibly.
Yeah,
I might have
you
seen
at least hear them.
somewhere,
Teachers
but-
make references to them all the time.
Yeah,
They just
they
expect
make
you to know what they
little-
are.
we didn't, like, spend
Okay.
a great deal of time on it.
We always assume that you remember whatever you were taught in years previous.
Yeah, that's a big
Is that a
assumption.
faulty assumption?
Normally.
Okay.
Sometimes.
Let's see, so that's
Well, those
what
all
they
make
mean
sense,
by
so.
dynamics. This next one's kinematics?
Yeah.
Right, okay. What kind of questions do they do? Are they super involved kinematics or are they very simple?
Oh,
You two are doing.
like last. All right, would kinematics be gravity and the speed an elevator drops?
Yeah, unless they
These
have
are
it
the example questions that they give you.
Okay, so one would be two. Okay, well, if you want to look at, do you guys all have this?
You should, whether it's with them or not.
Somewhere in- okay. Well, let's look at, number 2 would have been one of these for Newton's laws. So, TJ, if you'll just read 2.
Okay, so it says, 5.5 kilogram watermelon is pushed across the table. If the acceleration of the watermelon is 4.2 meters per second squared to the right, find the net external force exerted on the watermelon.
Okay, so which one of Newton's laws is this?
Second.
Second one,
Yeah,
yeah, so you just
F
have to put
equals
F
M.
equals MA. Which F here is already the net force, yeah, so just multiply those two.
23.1.
Do you really just do that in your head?
He has the paper in front of him, and I'm sure he's already done that problem.
No, it's 23.1.
Oh,
You did that in your head, just
Yeah.
like that? Mark?
It's not complicated.
Well, if it's multiple choice, you could also go 4 times 5 is roughly 20, a little bit above 20.
Yeah.
And I think you get a calculator too.
But then again, there's Mark, who
Yeah, in your head.
is like Newton, and he probably calculates logs at home when he's bored.
I have more important things to do. Cartoons.
Oh. Let's get serious.
Newton didn't have a TV or else we wouldn't have all this stuff.
I was going to say, Newton needed the TV.
Okay, kinematics would be question 1, I believe, on there. We'll get to that in a second, Mom. I believe, again, at some point in either your physical science, your some class 7th through 9th grade, the basic equation for kinematics is distance equals, you know what the line over a V means? Average. Average
Okay.
speed times time. Okay? So if you drive on the freeway at an average speed of 80 miles per hour,
Shame on you.
what?
Shame on you, first off.
75, I'm not speeding too much.
Too much.
Times, make sure another common trick is to put the wrong time in there. So if this is hours, you need it in hours. Times 3 hours, obviously how far did you drive?
45.
240, yeah. Okay? Some slower responses there. So this always has to be average. There's 2 types of speed. There's average, of course, and then there's instant. A good example of this, obviously I've done this for physics classes because it comes up enough. If I calculate how far I drive and then how much time it takes me to get here since I live in Ogden, I come out to about 54 miles per hour as my average. Now, I take the freeway. How in the world do I get 54? You know I'm not going 54 on the freeway. I'll
Yeah.
get murdered.
Because you have to drive through town.
Yeah, I have to go through Ogden, get there, so I'm including in this all the times that I'm going 0 if I get at a stoplight. 25 out my street, all that stuff.
If you go 25.
We have a lot of little kids, and
Oh.
that's about the time they go for the bus. So I usually go about 15 on my street, because we also have 3 sheriffs on my street. I don't speed on my street. Anyway, so average includes the whole range of time versus instant would be I take a speedometer reading, whatever, of what I'm actually going at that time. Okay? That makes sense? Pretty straightforward. Okay, now let's see what kind of question do they have there. I believe they give a little bit more,
Number 1.
yeah.
Okay, a ball rolls down a hill with a constant acceleration of 2 meters per second squared. The ball starts at rest